You might have seen this video where we take our first look into Meerschaum plugins. But in case you haven't, here's a quick recap. We undertook the challenge of building a data pipeline in as few lines as possible. To make plugins more approachable, we limited ourselves to writing a single line of Python. That's fine for demonstration purposes, but it paints an overly simplistic picture of all the things you can really do with plugins. So that's what we're setting out to do in this episode. Today, we're taking a deep dive into writing Meerschaum plugins. Hey there, and welcome back. My name is Bennett Meares. I'm a data engineer, and I'm the author of the open source library Meerschaum, which is meant to make your life as a data analyst easier. Plugins are powerful tools in the Meerschaum ecosystem. With plugins, you can ingest any data source, write your own synchronization algorithm, extend the web API, and even add your own functions as commands. Your teammates can install your plugins on your API instance, and you can even publish onto the public repo. But for now, let's focus on the first use, building data pipelines with plugins. Later in the series, we'll cover adding your own commands, extending the API, and sharing your plugins. So if you would like to learn about those uses now, check the plugins documentation linked in the description. And subscribe so you'll be notified about future tutorials. Today's episode is broken into two sections. First, we'll expand on what we started last time, fetch plugins. Then for finer grained control, we'll look at the sync function and its uses. Let's jump right in. In the last episode, we wrote a super simple fetch plugin. A fetch plugin is a Python module with a function called fetch declared, and this function is expected to return data. That's what let us build last week's plugin in a single line. All we had to do was return a data frame. Meerschaum takes the data frame we return, and based on its datetime bounds, it pulls a sample from the pipes table. It takes a diff of the two samples and then inserts the filtered sample back into the pipes table. There are some under-the-hood optimizations, depending on the database flavor. For example, for Postgres and TimescaleDB, it takes advantage of the built-in bulk insert functionality. And this is what makes fetch plugins so useful. All you need to worry about is getting the data into a data frame, and Meerschaum handles the rest. Last time, we glossed over the parameters of the fetch and register functions. The only positional arguments is this pipe object. Pipe objects are used to give us context to our data streams. This example register function that I've written returns a dictionary with two main keys, the column names as well as a list of IDs. So we prompt the user for a list of IDs. We take those IDs and we include them in the parameters dictionary. For example, if I run the register pipe command, using the plugin example here, it'll execute our function, and now it's waiting for my response, which we have in this line. I'm just going to type 1, 2, 3. And that should, per this line, include that into the pipes parameters. To verify that we've actually collected the IDs, run the command show pipes, and if you show a single pipe, it'll show you the attributes dictionary. So under the parameters key, we have the column names, which we defined here, as well as the list of IDs that we got from the user. So what is the parameters dictionary useful for? Well, in the fetch function here, which remember fetch is called during the sync pipes command, we can access this dictionary with pipe.parameters. See, on this line, I'm extracting the list of IDs that we collected from the user when we registered the pipe. So let's go line by line and see what I'm doing in this function. First, we're just importing some utilities, datetime, random, and a function called roundTime. I'm extracting the list of IDs that we got from the user. And on this line, I'm calling the function getSyncTime. This is another useful function for how pipe objects work. In this case, getSyncTime will return either none if we don't have any data, or the datetime object for the newest datetime value in our table. So let's look at the definition of the variable now. If the newest time exists, that means we have data in our pipe. We will use that timestamp for now. Otherwise, just grab whatever the current system time is. And finally, we add a time delta, so we advance the time by 1 minute. And on this line, I'm rounding the time down just so we can work with clean numbers. And finally, we return a dictionary. The size of this dictionary depends on the number of IDs that the user gave us. See here, we multiply the timestamp by the number of IDs, then we include the IDs provided, and finally we generate a random value once per ID. So let's take a look at generating some data. run the sync pipes command. That'll execute our fetch function. Run show data to show the most recent data for our pipe. Because we provided 3 IDs earlier, we generated 3 rows which are added to our table. Syncing again should generate 3 more IDs. Sure enough, just like we expected, we advanced the time step by 1 minute, and each row has one of the IDs we provided. Also, when you run the command edit pipes, the YAML file that it opens directly corresponds to the pipe.parameters dictionary. So let's go back to the function parameters. We talked about the positional pipe argument, but what exactly is this keywords argument dictionary? Well, simply put, Meerschaum includes a set of built-in keyword arguments, and the arguments we don't use get caught by this dictionary. If we want finer control of how our function behaves, we simply just include the arguments we want. Take a look at the help text to see the available function parameters. To see this text, run mrsm-h or the command show help. There are a lot of standard flags, but let's focus on 2 for the time being: begin and end. We can test out the flags we want to use with the command show arguments. When I run this command with the begin flag, it'll include begin as a function argument. So to make use of this flag in our fetch function, just add it as an optional parameter. In a later episode, we're going to look at writing your own commands, as well as adding your own custom flags, such as the ones I have here for a different plugin. I'd like to show you one of my fetch plugins to give you an idea of what's possible. I wrote this plugin to track my stock trades, and because the broker I use doesn't have an API I can pull from, I had to get creative. They use a company called Apex Clearing as a clearinghouse, and Apex doesn't exactly have an available API either, but they do have a mid-2000s looking export page. After poking around for a couple hours, I realized they were doing some fingerprinting to make sure users were requesting their data from an actual web browser. So I wrote a fetch plugin to spin up a Selenium WebDriver, navigate through the login process, and scrape the data I was looking for. That's really all this plugin is doing. It spins up a headless Firefox browser and scrapes some data. This setup function is called when you install the plugin to get the WebDriver cache installed, and this register function is called whenever a new pipe is created. It stores login credentials with this write plugin config function, and it stores the account number and datetime column names in the parameters of the new pipe. These dictionaries are for navigating the XPaths and other WebDriver stuff, and this dictionary enforces the data types in the data frame that I eventually return. Finally, here's the star of the show, the fetch function. These lines show the entire behavior of the function, and if I were to refactor, I would make them the entire body. Through whatever means, we get and return this data frame. It was enough work figuring out how to get the data in the first place, so at this point, I let Meerschaum take over and update the table for me. So this is a good example of the power of Meerschaum plugins. The data source never intended anyone to scrape the data, and even took measures to keep people from doing so. But as we've shown here, we can build a data stream with relative ease. The other kind of data plugin is what I call a sync plugin. A sync plugin with the sync function more or less wraps around a fetch plugin. That is, a sync plugin just requires one more step. Instead of returning data like a dictionary or a pandas data frame, like the fetch function does, the sync function returns the result of pipe.sync with the data inside. In fact, you can sync pipes outside of a Meerschaum plugin if you like. More on that in a later episode. But for now, think of the sync function as overriding the behavior of the sync pipes command, but just for your specific pipe. So you can still sync large batches of pipes, but only pipes with your plugin as its connector will execute this function. So what exactly does pipe.sync and the sync function return? It returns a tuple of a bool for the success status and a message. The message could be an error message, for example. There are 2 example sync plugins that I'd like to highlight. First, this is the SyncX plugin that I wrote for my master's thesis. It uses the sync function as an entry point for experimental synchronization strategies. It even adds custom command line arguments to tweak the behaviors of the experimental strategies. The other example I'd like to show is the Noah plugin. The reason I made this a sync plugin instead of a fetch plugin is because I wanted finer grained control over the syncing process, so I could tease out better performance while syncing large numbers of weather stations. Another situation where you would use the sync function rather than the fetch function is if you're syncing multiple pipes in a single batch. Here, I've tweaked the sync function of our example plugin. The first thing that we're doing is enforcing that the location is none. This is to make sure that data is only added when the parent is synced. We fetch the data like before, and we sync that into the parent. But these rows at the bottom are actually syncing children pipes. So I've made two data frames, data frame A and B. The first one just takes the data from the parent that only contains the ID 1. Data frame B contains the IDs 2 or 3. I've made two child pipes, child A and child B, with the same keys, the same connector and the same metric as the parent, except that I've actually added the location A and I've added the location B. You can change the instance to really be whatever you want. So for example, if you were going to do local caching, you could have the string SQL local, but in this case, I actually want the pipes to be on the same database. And then finally, I'm just specifying to use the same column names as the parent. These if statements are really only necessary if your register function is interactive. Because we prompt the user, I'm bypassing that register function by directly accessing the instance connector of the pipe. So if the child doesn't have an ID yet, tell the child's instance connector, usually it's SQL main, to register the pipe child A, and same with child B. Finally, we just pass those data frames into each child's sync function, and then we return a success. So what does that look like in action? Well, let's sync the pipes with our plugin as the connector, and that should have registered the two child pipes. So run the command show pipes with the connector, and just as we expect, here's the parent with the location none. We also have created pipes with the location A and the location B. Remember, we expect pipe A to only have rows with the ID 1 and pipe B to have rows with 2 and 3. So run the show data command and specify the connector. And sure enough, we get what we expect. The parent has all of the data, IDs 1, 2, and 3. Pipe A only has ID 1, and pipe B only has IDs 2 and 3. This tutorial was more in-depth than usual, so let's recap what we just covered. We talked about using pipe objects for context about your data streams, as well as extending your function with standard and even custom keyword arguments. We then looked at a practical example of using a fetch function for web scraping. Next, we examined the sync function and discussed ways to leverage it for complex synchronization situations, such as managing multiple dependent pipes. Well, today's episode was a mouthful. I told you there was a lot to cover. Anyway, your homework for this week is this. Write a fetch plugin to retrieve data from a website, and while doing so, make use of the begin and end flags. Check the docs if you get stuck, and remember, Meerschaum is here to make your life as a data analyst easier. Thanks for watching, and I'll see you next week.